Hi everyone, welcome to another episode of the tutorials on R for Bioinformatics. In today's video, I'm going to show you how you can generate pie charts using R. We will generate 2D and 3D pie charts. For the 2D, we are going to use the R function pie. And for the 3D, we are going to use the package Plotrix. So for this package, there's a function called pie3d in it. So we will use that to generate the 3D pie chart. So for the pie, it is an inbuilt R function. For the Plotrix, you need to first load it and then you can call the pie3d function. So if you don't have Plotrix installed, then you need to install it. So take note of that. And so by the end of this tutorial, you'll be able to generate plots such as the ones being displayed right now. So we have these plots. So there you go. So we have our 2D and 3D pie charts. Now let's continue. So for the 2D pie charts, this is the syntax. We will have to call the pie function, and then we are going to also indicate X, labels, main, and then COL. And then for the 3D, we will use the pie3d function. We will call it, and then we will specify X, labels, main, explode, and then COL. So these are the explanations for the options here and then here. X is a vector containing the numeric values to be used for the pie chart. So these numeric values are referred to as slices. Labels is used to give description to the slices. Main indicates the title of the chart. COL is used to indicate the colors to be used. And then explode is used to indicate the amount of explosion. So explosion is used to separate the slices from each other. Sometimes you would like one or more slices to stand out or separated from each other, and this is where the explosion comes in. So we will use that anyway. So when we get to the 3D, you will know what I'm talking about. So that's it. So if you want to get more information about the usage of these functions, then you can check these pages. For the options here, I'm using just a few of them, but all the options available can be found here and then here. So for the pie function, you can visit this page and then you can take a look at all the available options. For the pie3d, you also have to visit this page and then you can get all the options available. I will leave the links to these two pages in the description box, so just use them. Okay, now let's get back to the R interface. So for the tutorial, I've already prepared a script, and so in case you want the already prepared script, then you can check the description box and you'll find the download link. So this is the already prepared script, everything is there. But for this tutorial, I'm going to do it in an interactive session, meaning that I'm going to type and then explain. I want it to be interactive, so I'll just do it this way. But if you want the already prepared script, just check the description box and then you can download that. So that's it. And I also have some more tutorials on my Patreon channel, so if you want to check them out, just check the description box and you'll find the link there. It's $5 per month. Okay, so since we are going to generate pie charts, we need a data, or we need some values. We can use arbitrary values, but I thought it's important that we use a real world data. So I've already prepared one, which is available on one of my GitHub repos. This is the page. I'll leave the link to this page in the description box. So we'll use this file here, the variant count.csv, this file here. So to download it, you have to first click it, and then you come to this page. So when you are here, you just click on raw, and then you can download, but I'll show you how to download it in a second. So this data here is what? Variant count. So I have chromosomes here, and I also have some numbers here. So these numbers are variants that were identified on the chromosomes. So for each chromosome, the number of variants identified is given here. So this data was generated from another tutorial, by the way. So in that tutorial, I showed how to identify somatic and germline variants using VASCAN. So it is from that tutorial that I generated this data. So if you are interested to also learn how to identify somatic and germline variant, you can just check the description box for that video, or just click here to watch that tutorial. So that's it. So we will download the example data. Let me just start afresh. So if you're on this page, again, the link to this page in the description box. So if you are here, just click on the variant count.csv, then you'll be sent to this page. So when you're here, just come to the right side, click on raw, and after that you'll get to this page. So here you can just right click and then just go to save pages. So click it, and then you'll be asked to save it. So I will save it here, my desktop, and I have a directory called PyChart. So it is in this directory that I would like to save this file. So I'll save it. Perfect. So I am going to open the file. It's a CSV file, by the way, so you can just open it with any spreadsheet software. So I'll just open mine now for you to see it. So this is it. I have the data here. So I have the counts. Let me just zoom in a bit. Yeah, I have that here. Let me do this. Perfect. So I have the chromosome and then the count. These are the headers, and I have for each chromosome the number of variants that were identified. So that's it. Again, this data was generated from another tutorial. So just to the description box, and then you get that tutorial. Okay, so this is the data we are going to use. So now let's get back to our R interface. Perfect. Now we are in the R environment. So we will start the exercise. So we will begin by setting our working directory. So let me just put a comment here. So we are using this directory. I mean, this is my PC, so I'm using this directory. You have to use the appropriate directory. So I want to set the working directory to the directory which has the file, the data we are going to use. Okay, so setting the working directory allows you to just specify only the file names for the input data, and then it will be read for you. It also helps us to save all output files in the same directory. So that's it. So I will set mine first. You should also do same. So here I'll say set wd, then I'll specify my directory, which is this one. So this is my directory. So I will set it now. Perfect. After that, I am going to read the file or get the data. So I'll say, let me just say, get the data. Okay, by reading the CSV file. Okay, so it's a CSV file. So I'll say data. I'll say read.csv. Then I have to specify the name, which is variants counts .csv. This is it. So variants counts.csv. This is the name. So I'll open it now. Perfect. It's done. So now I can just say data, and I'll get my information. So I have my chromosome. I have my count. Perfect. Now we have that done. So because we are going to generate our pie chart, we also need to get the values or slices. We will get the values. Now before that, let me start with this one. We are going to use the pie function. We are starting with the 2D. That's what we are going to do. So let me first do this. I'll say 2D pie charts. Okay. Now I'll get the values. So I'll say get the values to be plotted. So the values will be what? Data dollar counts. So now I can just say values and I'll get my values. So in some tutorials, instead of values, they will say slices. It's still the same. So take note of that. Okay, now let's continue. So we will generate our first plot. I'll just say generate a basic pie chart. So to generate it, I'll say pie, and then I'll say values. And I'll say main equals, and I'll say variance counts per chromosome. Okay, this is it. So let's generate this plot. Perfect. So we have our first plot. So we have them here. So I have my values. That's the slices. I have 3 of them. You can see them here. That's why we have 3 slices here. Okay, and I have my title, the title for the plots. That is variance counts per chromosome. You can use any title of your choice. It depends on you. So I just thought I'll use this title here. Again, I'm repeating, you can use any title of your choice, but I decided to use this text. So just change it to what suits you. Okay, now let's continue. So you will notice we have 3 slides. You notice I did not specify any labels. Okay, so we have 1, 2, 3. So this is used to indicate the slices. We have 3 slices. So because I did not specify any label, remember here I have labels here. Because I did not specify the labels, the pie function automatically numbers the slices. That is what is used as the labels. So if you want to make your plot descriptive, then you need to add labels. So here we have chromosomes, 3 chromosomes. Each of them has its counts. So it will be good if we can use that information, the chromosome rather, so that whoever takes a look at this chart or this plot or this figure will know that chromosome 5, this is the slice, chromosome 1, chromosome 12, this is the slice, chromosome 17, this is the slice, etc. Okay, so 1, 2, 3, we can improve this. We can make the plots more understandable if you can add the actual labels. So let's add the labels now. Okay, so that's the next step. So to add the labels, you will still need to get the chromosome names. So I'll do this. I'll say, let me do this. Let's say add labels. That's the next thing. So here, I'm first going to repeat this command again here. I'll just put it here because each is a different activity. And then I'm going to add a label. So labels, I'll say data dollar chromosome. Okay. So the dollar here is used to specify the column. We are dealing with a data frame. We have rows and columns. Okay. So notice with the values, I said data dollar counts because I wanted the counts column. Now I want the chromosome column. That is why I'm using this one here. So that's it. In case you are new to R, this is what it means. Okay, so that's the labels. Now I have obtained the labels. I'll just call them again. We have CHR5, that's chromosome 5, chromosome 12, chromosome 17. Okay, so now that I have the labels, I can now generate my chart. So again, I can just call pi, I specify values, and then when I come to labels, I'll say labels equals labels. And then I have my main, which is equals to variance.counts. I'll just copy and paste everything here so that we proceed. Okay, let me paste. Let's see. Okay, perfect. So that is also done. Let's make sure everything is okay. Now we can execute this command. Perfect. So you will notice that instead of numbers, we now have the actual labels, the respective labels here. So we have them nicely done for us. Okay, so CHR5, CHR12, CHR17. Perfect. Okay, now let's continue. Now, with what we have, it's possible to customize the colors. You can use your own colors. So how do we do that? Let's continue. So let's say add colors. So for that one, I'll still copy everything here. Let me just copy them. And then I'll now add the colors. There are different approaches to add colors, but I'll just go with this simple one here where we manually create our colors, or where we manually input our colors. You can use color palettes and all that stuff, but I'll just make it simple. So we are using 3 colors. So I'll say C, red, green, blue. You can change them as well, but I'm using these colors. Perfect. So I have the colors. So now that I have the colors, I just need to call the pi function again. So I'll say pi, and then I have my values, labels equals labels, main equals, and then I have my text here. That's the title. So I'll just paste the title here. Okay, now let's execute this command. So before we even execute the command, we are dealing with colors. Okay, so before we execute the command, we have to add the colors option. So that will be comma, and I'll say col equals, now add my colors. Now let's execute the command. Okay, now we have that also done nicely for us. So that is for the pie charts. Okay, so let's continue. So we have the colors, we have our labels. What else can we add? We can add slide percentage. So I'll say add slide percentage. Sometimes we want the percentage. That will also make it more descriptive. Of course, we have this, but it's a figure. We should be able to interpret it. So we can add a percentage so that we know that for the total variance, in this case, maybe the number of variants identified on maybe chromosome 12 is maybe, or it takes about 50%, or it forms 50% of the entire variant, or 20%, etc. So we are going to add that percentage here. So to do that, I'll first copy and paste these once again. I'll paste them here. And then I'm going to add the slide percentage. So I'll say %, and then I'll say, let me just do that here. Round, say 100 star values, because each value divided by the total times 100, that will give us the percentage. So this is what it's going to be like over some values. We want to round it to 1 decimal place. So that is why this round function is there. So we can do this, all right, but because I want 1 decimal place, that is what I'm doing here. Okay, so I have that done. So let's continue. And let me say that this tutorial, to what helped me was that I got some online tutorial on tutorials points. I think that's the name. Let me just check. I have that here. I need to acknowledge that tutorial. So this tutorial also helped me. This is what helped me to prepare this video you are watching. So I just thought I would acknowledge it. So some of the information I got them from this tutorial. So I'll leave the link to this page also in the description box. Okay, now let's get back to the R environment. Okay, so we are getting back to our percentage. That's the slide percentage. So I have my percentage here, which I have computed. Perfect. So I have the pi percent. So I can just check and get that also here. So once I have the pi percent, I'll just add it. So I'll just say, I'll copy everything. Let me just retype everything. So I say pi, I have this one here. Let me check. I have pi and I have values. And then for the values, come to labels. So the labels here equals, instead of using the original labels here, I'll use the pi percent values as my label. So I'll just say pi percent. And then the rest remains the same. I'll just copy the colors and then the main. I'll copy all of them here. Let me do that now. Perfect. So now I can just do this. I'll execute. So now I have the numbers here. Okay, that's the percentage, the slide percentages. So I have that done here. Okay, so now I know the percentages. Perfect. So this is what we have. Okay, but then if you have it this way, then where are the labels? This 35.6, what does it mean? Which chromosome has this? We still don't know. Okay, and this is where legends also come in handy. So if you have our percentage, we can add our legend somewhere here or here, and then the legends, we can specify the color so that we know that this red color is for chromosome 5, and we also know that chromosome 5, the number of variants forms 30.2% of everything. And so we are going to add that legend so that the figure here becomes more understandable. So that is what we are going to do next. So that means that we have to add another section. We'll call it add legend. Perfect. So with this one, we will still call everything here. I'm just duplicating them so that you can easily understand what is being done. Okay. So I have that here, and then I also have to add this pi function here, like this. So let's first execute these commands. Perfect. So if you execute, you will still have this figure here, and then you add our legend. So you call the legend function. So legend, then we will specify the position where we want the legend to be. So I'll say top right, and then I'll say labels. Let me do it again. I'll say labels. So the labels here, we will use the chromosome names. That is what we have here. And then we're also going to indicate another stuff here. So we have CX equals 0.8. This is used to specify the size of the text. And then I'll say fill equals colors. The legend, we want the legend to include the colors. Okay, the same color that we used here, we want that also done for us. So let's execute this command. Perfect. So now you'll notice that we have what? Our pie charts, we have our slices, we have the percentage slices, and then we have a legend that gives a description. So we have red for chromosome 5, green chromosome 12, blue for chromosome 17. So now if you have this pie chart, we know that this is chromosome 5. Chromosome 5 forms 30.2% of everything, the entire thing here. That means the total number of variants, 30.2% are on chromosome 5. And so we can interpret this because apart from or aside from this information here, we also have this legend that maps the colors to their respective chromosomes. So that is what we have. So everything looks cool and then great. Now let's continue. Now we have done the 2D pie charts. So let's take a look at the 3D pie charts. Let's see. Okay, so I have my 3D pie charts. Perfect. Okay, now for the 3D, we are going to use a library called Plotrix. So I'll have to call it. So I'll say library. Now say Plotrix. I need to call this library first. And then I need to indicate my values. So again, I'll just repeat these ones. I'll repeat this and then this. I'll just copy these two here. And then I'll call my pi 3D. So I'll say pi 3D. I have that also here. And then I'll specify my values. Then labels. And I'll say equals labels. Then I add my title, which is main equals. So I'll just copy everything here. And then I'll paste. So now let's execute this command. Perfect. So we now have our 3D pie charts. Sometimes you would like one or more slices to stand out. So that means that you would like some of them to be separated from each other, or you would like all of them to be separated. So what you are going to do next is to add this option called explode. So this explode option will allow us to separate each of these slices. So they'll be separated from each other. So that's what we are going to add next. So let me say add explosion. So again, I'll copy everything here. We'll just copy them and paste. And then when we are here in the options side, we'll add, let me just add it here. I'll say, okay, let me just start afresh. So I'll just say pi 3D values labels equals labels, and then explode equals, let's say 0.1. Then I'll add my main. I'll just copy and paste the title. Perfect. So we have that done. So now let's execute this command. Perfect. So once you do that, you realize, or you will see that the slices have been separated from each other. So this is what the explosion or the explode option here does. So you can increase the value. Let's increase and see. So you will see the explosion, okay, the degree of explosion, how these slices are being separated. So the higher the value, the wider the separation. I'll change it back to 0.1. Okay, so we have that done. Perfect. So this is how we generate 2D and 3D pie chart. Now we have generated a plot, but sometimes you may not have access to, let's say, RStudio. Maybe you're working on a command line and you still need to save the figures. So how do we do that? Let's do that next. So now we are going to look at saving the plots to an output file. I'll just demonstrate here using just one or two examples. So if you are going to save an R plus to an output file, then first of all, you need to open a file. For this tutorial, we are going to use a PNG file format. So I'll need to first specify that. So I'll say PNG and I'll say file equals, and I'll say pie underscore charts underscore variants counts.png. So this is it. Let me just put the header here. So I'll say give a name for the output file. So I'll do that and then I'll just specify this. So this is the name that will be used for the output file. So the PNG will be activated. That means that the plot is going to be saved in an output file, and then the output format is going to be PNG. Now let me add my plots. Let's use this one here. So I'll just paste them here, and then I'll execute this command. Perfect. So after doing that, then that means we have plotted our pie charts. So now we will need to finally save the file. And so let's save the file now. So to save, we will just say dev.off, and then we execute this command. Perfect. So once we do that, the file will be saved. So the file can be found here. If you go to the directory which you used as the working directory, let's scroll up. Remember, we set a working directory. So just go to that directory. So when you go to that directory, you'll find the output file. So this is the file. This is mine. So I'm going to open it now. So this is it. Okay, so this is the pie chart. You can also do same for the 3D pie chart as well, but that one I'll leave it to you to try your hands on. Okay, so if you're working on a remote server, let's say a Linux server where you don't have access to a graphical interface like the RStudio, you still need to find a way to save your plots or figures, and this is where this approach comes in. Okay, here, and that is what we have done. And so this is how we generate 2D and 3D pie charts in R, and this is also how we save the outputs to a file. Okay, how we save the chart, the pie chart, to an output file. So here we use the pie and then the plot tricks, but it's possible to use other libraries to generate your pie charts. And so what I'm going to do next is that I'm going to try to look for other tutorials, look for other packages that are used to generate pie charts, and then I'll try to make tutorials on those as well. So that'll be all for this tutorial. Again, if you want the complete Rscript, just check the description box. You'll get a download link, and then you can use that. If you also want more tutorials with more scripts already prepared and ebooks, you can check my Patreon channel and you find more materials there. So that'll be all for this tutorial. Thanks for watching, and I'll see you in the next session.